So in October 2006, things really changed in Wisconsin and the whole Great Lakes region after VHS was found. Because all of a sudden we had a disease we had never seen before to this magnitude. And we had to figure out what to do.
When VHS was discovered in the Midwest, that was a surprise. It was the first time it had ever been found in this region, and it was a new strain that had been found. So it raised a lot of alarm bells, and it instantly caused big headaches for people who managed fisheries.
So with the outbreak, the challenge was a restriction on moving fish from one state to another. And we had to figure out how we were going to do that. And no one really knew to begin with. And there was a lot of effort that was put together by federal agencies, state agencies, fish farmers combining.
With the arrival of VHS in Wisconsin, the Bureau of Fisheries Management changed significantly how it operated throughout the entire state. We changed how hatcheries deal with eggs, how they move fish around. We implemented biosecurity to make sure that we kept VHS out of our hatcheries and to make sure that we didn't spread it to those populations where we routinely stock.
One of the initial problems we identified was that this virus was very hard to test for. Viruses are tricky. They can be grown, but to get a virus to grow it, you need to harvest the organs of a fish. So there was no way before our test came along to test for this virus without killing the fish. So we immediately set out to develop a non-lethal test. And the test that we developed, which is an ELISA test that tests for antibodies to the virus. And that's important because with an antibody test, you're not looking for the virus itself, you're looking for the fish's immune response to the virus. So if you get a positive antibody test, what you know is that the fish has been exposed to the virus in the past. It may not have it now, but the antibodies being there tells you that at some point in its life, it was exposed to the virus and mounted an immune response. So it's a powerful tool for understanding the history of infection of a population with a virus.
So the assay that we developed here is an antibody assay. So we take serum from the fish and we look for antibodies, or in other words, the response to the viral hemorrhagic septicemia virus. And then we take that serum and we use it in an ELISA, which is an enzyme-linked immunosorbent assay, and we can tell by color development or the lack of color development actually in this assay that antibodies are present.
One of the great promises of Dr. Goldberg's project is that it would allow us to know where is VHS potentially a problem and where is it not a problem, which species are carriers, which bays or shoreline areas have populations that are reservoirs for VHS versus are not. So if we had a good map, if we could resolve this unknown where is it and when is it a problem issue, then we would know what would be safe to do in terms of barrier removals that could then enhance the fish populations and the fishery potential of the Great Lakes.
We should expect the rate of invasive species entering the Great Lakes to increase in the future, especially with the high rates of shipping and commerce and the dumping of ballast water. And we would likewise expect an increase in the rate of invasions of emerging pathogens that come with many invasive species.
Diseases like VHSV or pretty much any wildlife disease, pick your disease, there is a window. When these diseases first appear, if they're invasive diseases, they're containable. If they get too widespread in time or space, if they start infecting many other species in many other locations, it becomes harder and harder and harder. We may be in that window now with VHSV. If it's not everywhere in Wisconsin, that means we can contain it and we can prevent further damage from the virus. I can't see any way of making those sorts of choices without accurate science. We have to know where the virus is, we have to know where the virus isn't, and the only way to make that determination is with scientific diagnostic testing. There are debates in society these days about the value of science for making these sorts of decisions. All I can say is that without the scientific data that our project will generate, we would be guessing 100%. There would be no basis for making any decision, and we would almost certainly make some wrong decisions, and we would doom the state of Wisconsin to having this virus throughout every water body in the state in some number of years. With science and with careful planning and science-based management, we can stop that from happening, and we can really protect and preserve Wisconsin's fishing heritage.